This is an example of a deterministic model. So we need to calculate the economic order quantity in part 1 and 2 for two different demand scenarios. And also we need to calculate the effect on total yearly cost by falsely assuming that the demand is 200,000 instead of 242,000. Let's do our calculations. You have already got this Excel sheet that you can use to do the calculations. Here we can see the two demand scenarios that we talked about. So in the first demand scenario, the yearly demand is assumed to be 200,000, and in the second one it is 242,000. We have fixed cost S equal to 32, we have cost per unit C which is equal to 8, and we have interest rate equal to 0.1. To do our calculations for economic order quantity, if you remember, we need to have holding cost rate. Here, the holding cost rate is interpreted as the opportunity cost. The money that has put on the items that we hold in the inventory could have been invested in some other place, so this is the opportunity cost that we need to pay for holding them in inventory. To calculate H, I need to multiply the item purchase cost or cost per unit of item by the interest rate. So it will give me the holding cost per unit of time, per unit of item. So I have H, I have S, I have D, so I can calculate the order size or economic order quantities. So in the first part I have the first demand scenario. So to calculate the economic order quantity I need to write square root of 2 times D times S divided by H. It is 4,000. So we have in the next part number of orders per year. Per year we have a demand equal to 200,000, and each order that we make is of size 4,000. So if I divide the demand, the yearly demand, by the order quantity, it will give me the number of orders that we make per year, which is equal to 50. Then we can calculate the holding cost. If you remember, the holding cost is the average inventory multiplied by H. Average inventory is Q over 2. Q is 4,000 here, so what I need to do is to divide 4,000 over Q by 2, which will give me the average inventory, and then multiply it by the holding cost, which is 0.8, and it is equal to 1,600. For the ordering cost, I need to multiply the ordering cost per order by the number of orders that is made per year. So it will give me 1,600 as well. And as you can see, at optimality, at an order of size 4,000, at size EOQ, at size equal to EOQ, the holding cost and ordering cost are equal to each other. And total cost is, as you know, the summation of the holding cost and ordering cost, which is 3,200. In the second part of this example, we need to do the same calculations, but for another demand scenario. For a demand scenario in which we have a yearly demand equal to 242,000. So again, I will do a calculation for EOQ first. So it is the square root of 2 times demand times order cost divided by H. which is the inventory holding cost. So it is 4,400. Then the number of orders made per year is the demand divided by order quantity. Yeah. And then holding cost is simply the average inventory, which is Q over 2 multiplied by inventory holding cost. And then we have ordering cost, which is equal to the number of orders that we make per year multiplied by the ordering cost per order, which will give us 1,760 for both holding cost and ordering cost. And the total cost is the summation of these two cost terms. Yeah, and we can see that for a higher demand, of course, the total cost is higher in these two parts of this example. But in part 2, it also says that if we mistakenly take an order quantity equal to 4,000 and while the demand is 242,000, then what would be the effect of this mistake on the total costs? So I'm going to do the calculations for the total costs, but this time with an order quantity equal to 4,000 for a demand equal to 242,000. So first I will start with the holding cost. We know the holding cost is simply the average inventory multiplied by the holding cost unit per unit of product per unit of time. And then we have ordering cost. Ordering cost is the order cost per order multiplied by the number of orders made per year. So the number of orders made per year is in fact the demand divided by order quantity. So it will give us an ordering cost equal to 1,936. And I can calculate the total cost as the sum of the holding cost and ordering cost. And here I want to see the impact of this mistake on the total cost. The absolute increase in the cost is equal to, this is the mistake, this is the value that we have got if we make a mistake in the order quantity, and this is the optimal cost. So the difference is 16. And we can also calculate the percentage, which will be simply the difference of these two costs divided by the optimal cost here. So it is about 0.45%. In fact, as you can see, the difference, of course, we are making an order which is about 10% smaller than the optimal order size, but as you can see, the percentage of the increase in the total cost is rather small. It is 0.45%, and this is because of the fact that the total cost curve is relatively flat around the optimal order quantity. So that's why we can see that small deviations from the optimal order quantity will have a small impact on the total cost.